Welcome back. So we have a different set of students with another set of exciting ideas about scientific temper joining us here. So let's start out with our second phase of the talk show. So I would like to start with the same question which was posed to your friends a while back. What is scientific temper and why do you think it's very important from the society's standpoint?
Scientific temper is actually the interest in science. It tells us that how science works, or it shows the interest for you in science.
Okay, I believe that scientific temperament is a process. It's first coming up with some hypothesis, guessing something, and then analyzing the hypothesis, and then questioning the hypothesis. So this is a continuous process of developing science, of developing something which will be useful for the society. That's what I believe scientific temperament is about.
Okay.
You can't exactly define something as scientific temperament because it is something where you show an open attitude. It is somewhere where you're ready to accept changes to present science. Application of science in daily life is what scientific temperament is all about.
Scientific temper is an attitude. It's a kind of attitude which keeps you open to everything which has evidence.
So, but
Yeah.
what about cases where it cannot be proved, about where the experiments cannot be conducted on such large scales?
Okay, can you give an
Even
example?
I want to question on that because there are few theories like the huge theories like the string theory, relativity, quantum mechanics. Now, how do we test those?
Perfect. Yeah, go ahead.
And a simpler example would be that of the mass of the Earth.
Yeah.
Okay, you can't possibly imagine they took the Earth and weighed it on a weighing scale or something like that.
Right.
All they did was find the approximate density and then multiply it so many times by the approximate radius. So everything is just an approximation.
I believe in analogies. Like you can find the diameter of the moon by similarity, it's a very common example. Keep the thumb in front of you and then you look at the moon. I mean, it's just a simpler form of experiment, but then it gives you kind
Sure.
of good results.
Got it. Let's say, basis science, we've come out with an approximation as how Sahit has pointed.
You know,
Okay,
my-
it's just an approximation. Case 1, we have an approximation which is backed up by certain evidence. Maybe not very great, but there's certain evidence. Case 2, somebody says, my book or my gut feeling tells me that the mass of the moon is 100 kilos. What do you think holds more credibility?
Obviously, the approximation holds more, and that's what my point is here. The first, the gut feeling which you are talking about is what is pseudoscience, something which you feel is right but hasn't been proved experimentally. And science is something which were approximation. What we have to understand here is science cannot be defined. It's a process. Science is always an approximation. Science can never be perfect.
Sure, science is not infallible.
Yeah.
The legendary scientist Newton's theory was falsified in the context of relativistic speeds. So that's a very good
Yeah,
point.
that was what
That
my
we should
point
always
was.
have this humility to accept that our theory could be falsified some other day. I think that's a great point.
Science is always open to contradictory theories.
You mean to say science is more open? If
Yes.
you're showing me evidence, I'll change.
Yes.
I can summarize that in one point. It's not about answering the questions, but it's about questioning the answers.
And previously you had told that there were many limitations in the field of science. So what I think is science is it's not just based on our observations, it's about imagination. Like for example, you just see that here it's all empty, you just feel air. But what's inside, you try to imagine and then implement it, like your imaginations. And based on your imaginations, when you conduct an experiment, and if it's by chance, if it turns out to be true, then I think that's an excellent way of trying out new things and discovering new things.
Absolutely. There were several great discoveries which were accidental. I mean, the legend has it that Kekule dreamt of the structure of benzene. It was a dream. And then later experiments proved it to be true. There is a lot of creativity in science as well. We imagine, we think of a theory, and then we test it out experimentally, and only if it is correct, we believe in it. In the conventional mode of education right now, even when you conduct your experiments in the lab, you're not doing it to explore, but you're doing it to confirm what you already have in your mind. So you're doing experiments not for the sake of exploration, but for the sake of confirmation, which defeats the purpose of science. So how do you think that can be rectified? Because we have practical sessions in our schools, but we don't try something new. How do you think we can change that?
Before starting up a lesson or something, what the teachers have to do is, okay, for example, let's take the case of chemistry. And they start up the class of atoms and molecules. So first they need to question the students, like, what do you think this is made of? And why do you think it is so? So it generates a kind of curiosity in the students, and what this leads to is finally exploration.
So you said that we must follow the principle of exploring. That's the principle of science, but we're not following that. Because what we do, we go to schools, just get grades and get into MIT, BITS or IIT. That's what we want. Science is not about that. Science is about exploring and getting to know much more new things.
I would like to add one more point. I believe that we need to go out of the syllabus. In fact, if you want to go for IIT, if you're giving an entrance exam for IIT, I believe that sticking with the standard sources of books will not help you. Going abroad, going away from the standard sources of books, and the teacher should help you to do that. You need to go questioning whatever is there, and then going away from the books, and ultimately you learn more concepts. You learn the concepts rather than just solving how to solve the problems out of the formulas.
Yeah, so that's the basic question here. What sir asked us was how you're gonna implement that in the schools rather than what you want to do.
Yeah. How do you balance both
How
of
do you
them?
balance both of them?
You have to expose students to existing body of knowledge. At the same time,
You
that
also
should
have
not
practical-
compromise on the
practical-
child's exploration.
But then you have to even consider students who do not want to explore. They just study science to have a basic
No, we're not
understanding
talking
of
of science alone. We're not talking of science as a subject alone. We're talking of history. We're talking of say languages. I mean, when we talk of scientific temper, we're talking of questioning anything and believing in something with evidence. So that's a mindset.
It actually depends on the students whether he or she has a will to explore or just wants to study, get grades.
So do you think it's all right if a student doesn't want to explore?
Maybe they don't want to explore all the aspects.
Do you think that then the teachers have failed if a child doesn't want to explore?
Yes.
Probably if the teachers haven't failed, but probably the student is the most intelligent guy in the world, but is only lethargic or lazy, and so it is the
No, but
student.
don't you think we have that curiosity inherent in us to challenge something?
So actually my question was, I think that most of the time those teachers make a mistake is that suppose it's a teacher of biology. So that teacher in the basic just tries to stick to biology. Don't just get away from biology and take practical experience into consideration. So I think that can be a problem, and that's where interdisciplinary scientific research comes. Because in interdisciplinary scientific research in today's era, this topic is very important, because now onwards we want to get technologically more advanced, and for being technologically advanced, if I discuss something in physics, I need to apply it in biology, I need to apply it in chemistry. Only then it's going to be accepted by the world today, or else you discover something, it's just useless. It's just a craft.
Absolutely.
Yeah,
So
that's why.
this is the age of interdisciplinary sciences, and you borrow ideas from everywhere.
Now, presently in the number line, there is 1, 2, and 3. But for some other civilization in some other planet, it might be 2, 3, 1. It doesn't. But even though it might not be correct for us, it might be correct for them.
Sure.
So the basics are not what decide the exploration process, because
Sure.
it depends on your mindset.
Sure.
So that's
Definitely.
See,
So today I might be using one branch of mathematics. You might use a different branch of mathematics to explain. That's a valid point. Yeah.
the basic principle of basics is to get something new, like the theory of relativity. It tells that how things work in supermassive scales. Now I have a supermassive star. It collapses within itself and come to molecular level. So that's where we come to understand about our basics. It's for getting something new, we need to get something which is already done.
Sure. So, but my question here is, how do we balance this confirmation with exploration?
Yeah, so sometimes now presently, because of the technological advancements and the vast reach of technology, you have computer softwares which are willing to give you which are willing to explore in different fields, and you can actually explore in fields where you can't do that physically. For example, if you have a reaction of a sodium bicarbonate with a sulfuric acid, which is a neutralization one.
Yeah.
So you can't actually do that because that's a very explosive one, whereas you can actually do that. People already know the products. You can actually think of the possible products.
So you mean to say there are more explorative capabilities due
Right.
to technology?
Yeah.
Yeah, I would suggest peer-to-peer learning. I believe that every person has his own ideals, and school should advocate peer-to-peer learning. Everyone comes up with their own ideas, and then the teacher tells what's the correct idea, and then you can combine peer-to-peer learning with practical science. Then it will be better doing it actually in laboratories and actually discussing it
And
before.
how do you think we can sort what Karthik has pointed, that when you do these experiments, you tend to think of, how do I confirm what I've already seen? Hey, the pressure should go up. Hey, it's gone up. My experiment is a success.
There's
How do we get out of that
There's
mindset?
another way of doing it. You
Yeah.
can do research-based learning as well. For example, instead of giving a student one paragraph to learn and understand from, you give them a question. And then they try to find out the answer of the question, and in that process they learn.
Can I think of something which I want to find out and explore by myself rather than what's already, told to me?
You know what you can do is, once the child learns the theory, you do not assess them on the basis of their theory. You assess them on the basis of how they apply the theory to do something else, which is not there in the text.
Sure, okay, I have to conclude. Sorry guys, I'm sure you all have a lot of interesting questions and answers. So this brings us to the conclusion of the program. Today we had young minds from different schools of Hyderabad who've shared their views on what is scientific temperament and why is scientific temperament very important in a society. And very important part of our discussion has been how do we blend our theory with practicals. So our next show is actually on the same topic on integrating formal sciences with empirical sciences, which is being organized at the same place at 10 TV studio on November 20th. So please do stay tuned to the next program of Sciencesation, because that is around the same topic. How do we train our students to both understand abstract topics as well as be able to think of experiments to test theories, both old and new theories which they would have constructed. So please do stay tuned to 10 TV and Sciencesation for much more interesting content on science and scientific temperament. Thank you for watching, and happy Children's Day once again. Thank you.